Hi, today we are doing and reviewing sections 4.1, 4.3, 4.8. These are review notes. They cover right triangle trig, applications to right triangle trig, and all of the basics that we learned in 4.1, converting back and forth, reciprocal and our identities, coterminal, those kind of things. But our focus today is definitely using the calculator to do it. So the first set of problems that we're going to do are these kind of problems, which are just using the calculator. For these problems, we're going to draw an angle. So we have a picture to work from. We're going to identify the mode on our calculator because that's going to change from problem to problem, and we got to make sure we're in the right mode so we get the right answer. And then we're going to round our final answers to 3 decimal places. And these part of the last 4 problems here, or 5 problems, are application problems. And in application problems, remember, we draw a picture of the situation, we label everything in our picture, and then we go to work figuring out what trig identity we're going to use. We isolate the unknown, and then we go to the calculator in one step. But before we get to those problems, I want to review some things to remember. And the first one is the biggie. Make sure you're in the right mode on your calculator, and that may change from problem to problem, so that should always be the first thing you check for. In case you have forgotten how to do that, then on your calculator, you go to your mode button, which is right up here under quit. You get this menu, and you're looking right down here. And most of the time, if you've done the reset, remember it's going to be right there on radians. And see how that's highlighted, but if you wanted to change it, you'd arrow over to degrees and press enter, and now you can see how that's highlighted. Okay, so anytime you reset your calculator, though, remember you're in radian mode, so you have to check the problem and see which way you're supposed to be. All right, then we want to remember that when we're doing reciprocal functions like secant, cosecant, and cotangent, there are no secant, cosecant, and tangent buttons on the calculator. We only have sine, cosine, and tangent. So those are the ones that you have to use when you're doing your problems, which means if you need to do a secant problem, we're going to use the reciprocal identity so that we can use that cosine button on the calculator. We just have to remember to put it in a fraction, 1 over cosine theta. So cosecant would be 1 over sine theta, and cotangent would be 1 over tangent theta. And those are all identities that we had memorized earlier in the unit, so none of that has changed. Then we want to make sure that we're giving our answer in the correct sign, because sometimes your answers will be negative, sometimes your answers will be positive. So that's always a big one. Check that and make sure you record it properly. And then round answers to the thousandths place unless the directions tell you to do otherwise. And sometimes they will if it's a money problem, or even sometimes in triangle problems, they'll tell you to just go to the 10th or the hundredths place. But our standard is 3 decimal places to the thousandths unless instructed to do otherwise, or it doesn't make sense like you're talking about money. On application problems, we always draw the picture and we fill in all of our information so that we're working with correct sides and links and all that fun stuff. And then finally, when you're doing a regular problem, you're going to draw the angle on the axis to make sure your answer makes sense in the end. So you should be able to look at the picture on your axis and tell whether what your answer you just calculated on the calculator makes sense. So we want to have a little bit of number sense to this. Okay, so we're going to start with this first set of problems, which is right here. And for this set of problems, we're going to draw the angle. We're going to go to the calculator. We're going to identify the mode that we need to be in and make sure our calculator is set accordingly. And we're going to have that work on our paper to support what we put in the calculator and what our answer is. Don't just say, put it in the calculator. That's not supporting your answer. You need to tell me what you're putting in the calculator. So any work where you're not telling me what you're putting in your calculator, unfortunately, I can't give you credit for it because you haven't supported your answer with mathematical reasoning. So these 4, we're going to do all that way. So let's start with the first one. So on the first one, we are calculating cotangent of 325.2 degrees. So the first thing I'm going to do is go to my calculator. Get it down here where you can see it better. And then I am not going to do any problem work at all until I check the mode. There's a degree sign on that problem, so I'm going to press the mode button on my calculator. I'm going to go down and I see that right now my calculator is set on radians, so I'm going to arrow over to degrees and I'm going to select that. So now you can see that my degree is highlighted, and then I'm going to do second quit. Okay, the next thing I'm going to do is I'm going to draw my picture. So I know this is a positive angle because it is a positive number. So that means it started here, it opened counterclockwise all the way around down to here, and that is 325.2 degrees, okay? So when I calculate this on the calculator, I don't have a cotan button, so I'm going to set it up with my fraction using the fraction 1 over tan of 325.2. So when I do that on the calculator, I'm just going to do alpha y equals. I'm going to get my fraction. I'm going to put 1 over, and then I'm going to press the tangent button, 325.2. I already have my calculator in degree mode. I hit enter, and it gives me this decimal. Okay, so this decimal is right here. That's the full length of my calculator. When I go to 3 decimal places, that means I'm rounding right here to this 8, and the 8 behind it is bigger, so I add 1 to that, and my final answer is going to be approximately negative 1.439. Remember to use your approximation bars because these are approximations. They are at some point rounded. There's more to this number in the calculator. You just can't see it, so it's taking care of that right here. We're going to 3 decimal places, so we're taking care of that right here, so we're going to have approximation signs. Well, does that make sense? Let's see. If I actually opened this angle to this particular spot instead of going all the way around my circle, then that would be negative 1.439, which means if this is using my approximations, this is going to be negative 1.57, and this would be 0, then it makes sense that negative 1.439 would fall in that 4th quadrant. So hopefully you remember some of that number sense from things that we've talked about. Problem 2 is secant of 3 pi over 5. So we're going to go into our calculator and figure out where 3 pi over 5 would be. And so you kind of have to do some reasoning and thinking about what we know so far. So here is my graph. It's actually in the 2nd quadrant. And I could always kind of fake that out a little bit if I needed to right now till I'm more comfortable working in radians and I could figure out what that is as a degree, which is 108 degrees. So don't panic if you're not there yet. Now I notice that my mode, because this is in radians, needs to be set to radians. So I go to my calculator, I press the mode button, I go back down and change it back to radians before I go to the home screen. Okay? So once I've done that and I know where this angle should be, then secant has a reciprocal of 1 over cosine. So, oops, sorry, I moved that paper there. So 1 over cosine of 3 pi over 5. So I go into my calculator and I get 1 over that. And I would actually probably do a fraction here too, just to keep everything working and looking like my paper, which is always a splendid idea. So I would do secant alpha, and then I would put 1 on top, and then I would do cosine, and then I would do secant alpha, and get my fraction down here and put 3 pi over 5. And close that out on the bottom and get out of my fraction there so I can make it look exactly like it does on my paper. So really, guys, there's no excuse to miss a problem like this. If you're missing a problem like this, it's user error because you're not entering it correctly, and you have lots of templates there to help you do so. So when I execute, I get negative 3.236067977 and a whole bunch of other stuff. So I am going to round that to 3 decimal places, which means I'm rounding to the 6 right here. There's a 0 behind it, so it's going to be negative 3.236, again with the approximation. So on 3, we're converting. So we're not worried necessarily about the mode on the calculator because we're going to be going back and forth. So what I would do here is I would probably just start and put my calculator mode on radians. Since that's probably what the standard is going to be set to be anyway. But really it won't matter either way. Okay, so I have this here. So here's what's going on. Now, if I were doing this by hand, I would, just probably put the 180 over pi because that's our conversion factor. I would cancel out my pi's. So I just have 5 times 180 over 11. But really, all you're doing is just putting in the problem as you would do it. So I would do secant alpha, I would get my fraction, I would put 5, pi symbol over, 11? Sorry, 11. And then you can go right outside and do alpha y equals, let me try that again, folks. Alpha y equals, get over here where you can see what's going on. And then I would have alpha. We already got that. Second quit. All right, let's go back up here and put this stuff in, shall we? Sorry about that. 5 secant pi over 11. And then I'm going to go out beside it and hit my times sign and do alpha y equals and get another fraction that's going to have 180 on top and pi on the bottom. And so I can literally put it in like this and get my answer. It wouldn't matter if I was in radians or degrees, so let's see what mode I'm in. Oop, I calculated that in degrees. Let's go ahead and change it to radians so you can see that I would get the same thing either way. Okay, so now what does the answer mean? Well, it means that that's degrees because I'm converting it from radians to degrees. So when I get this decimal, I got to have that decimal symbol, so it's 81.818. Because I'm rounding to here and there's a 1 behind it, which is less than 5, so I get 81.818 degrees. You could have also put that in one big fraction and put 5 times pi times 180 on top and 11 times pi on the bottom, and that would have been another way you could enter that into your calculator. All right, on number 4, we're doing cosine of negative 2.378. So the first thing that I would notice is that my calculator needs to be in radian mode, so I would go into my calculator, press the mode button, and make sure that I have radians highlighted. And then I'm going to draw a picture, so negative 2.78 is going to be roughly right there. And then I'm going to use the reciprocal for cosine, which is 1 over, I'm sorry, we don't have to use the reciprocal because cosine has a button on the calculator, so I'm good there. So that's what I'm putting in. So when I put that in my calculator, I get this negative number, and that's okay. So we're going to have negative 0.722. So that's going to be my answer for that problem. All right, the last set of problems are some applications to review. So this one is a 20-foot ladder makes an angle of 56 degrees with the ground as it leans against a building. How far in feet up the wall does the ladder reach? So here's my ladder. It is this angle measured with the building is that 56 degrees it's talking about, and we're trying to find this distance here. So I called the distance at the bottom X. I called the distance going up Y, just so I had some specific values to use. Okay? So once I have that labeled, then I am trying to find the side up the wall, right? So this side right here. So I'm going to use the hypotenuse that we're given, and I'm going to use the opposite side. So the trig function that uses opposite and a hypotenuse is sine. So I'm going to take sine of 56 degrees equals something over the length of the ladder, which is 20, because that's the hypotenuse. I'm going to isolate y by itself, and so I get y equals 20 sine of 56 degrees. So what mode does my calculator need to be in? It needs to be in degrees, so I'm going to change it to degrees. And then I'm going to be able to go into my calculator and put in 20 sine 56, and that's going to give me that. Okay, so that means that the ladder is 16.581 feet up the wall on the building. So notice that we have to have units in an application problem, and we went to 3 decimal places just like we did in any other problem. And so that's what I would be expecting to see on your paper. Probably, obviously not that, but I would expect this and this. I would expect your picture, and then I would expect your explanation to that application problem. Problem 6, the arc length of a circle is 15.26 meters, and the radius of the circle is 18 meters. What is the angle measure in degrees rounded to 3 decimal places? So if the arc length is of the circle is 15.26 meters, we're wanting to find the angle measure in degrees. So first off, we're going to draw a picture. So I have my picture and I have this information. So I know that I have a circle and I know that the radius is 18, and then I'm talking about a theta angle in here that is corresponding to this arc on the outside of the circle, which is 15.26 meters. And so what we're trying to find is theta. So when we work on that, then we're going to have our formulas. The arc length equals radius times theta. So the radius would be half of, the arc length, that's S, would be 15.26. Then we have the radius, which is 18, and we're trying to find theta, which would be in radians, remember. So to do that, I need to get theta by itself. So I'm going to divide by 18. So I have 15.26 divided by 18, and that is the radian measure. So the answer had to be in degrees. So since we calculated in radians, then we're going to multiply by our conversion factor of 180 over pi, because remember that's radians. So think about wanting the units that are going to cancel on the diagonal, just like you do your dimensional analysis. And then we'll end up with our answer that's actually in degrees. So we get 48.57 and some other numbers. And so to 3 decimal places, this is what you have, which means the measure in degrees for theta is 48.574 degrees. Don't forget your degree sign, because remember we have multiple units of measure and we have to designate anything that's a degree with a degree sign. Otherwise, it will be calculated as a radian measure. All right, number 7. Find the length of an arc of a circle of radius 28 meters, intercepted by a central angle of 128 degrees. So the first thing, again, we would do would be to draw the picture. So we have our picture here. We have our circle. We have the radius of 28. We know that it's going to be opening this way as a positive angle, and that's 128 degrees. What we don't know is that length of the arc right there. So that's the givens that we have, and remember that's 128 degrees, and that is the arc length that we're trying to find. So then we're going to change our angle to radians so that we can use our formulas. So 128 degrees times pi over 180 gives me 32 pi over 45. And then I can go to my calculator and put it in just like it is if I want. 32 pi over 45 times 28, because that would be the radius. And I get 62.5526039. Why do we need this to be in radians? Because remember that our models are in radians. So the arc length intercepted by theta is approximately 62.553 meters long. All right, we're almost there, guys. All right, question 8. The sun is 22 degrees above the horizon. Find the length of a shadow cast by a building that is 520 feet tall. So again, the first thing we're going to do is draw a picture. So here's my picture of the situation. We have the building. We have the shadow. I have had people ask me this in the past, but shadows are on the ground, not up here. So make sure that you get the shadow in the right spot. And then we're talking about this angle right here that's 22 degrees. My sun is up here. It's casting the shadow down. I don't know the length of the shadow, but I do know the building is 580 feet tall. So I know that what I'm trying to find is the length of the shadow down here. So I'm going to have to use tangent because I'm given the opposite and I need to find the adjacent. And the trig function that uses opposite and adjacent is tangent. So I'm going to have tangent of 22 degrees equals 580 over x, because that's what we're trying to find, the adjacent. I isolate x by multiplying both sides by x and then dividing both sides by tangent of 22. So this is what I'm going into my calculator with. And I plug that in, and I am in degree mode because I'm dealing with the degree angle here. And so I get this on my calculator, which makes this, when I round it to 3 decimal places, 0.550, because 3 is less than 5, so we won't change that. And we do need the 0 because we're supposed to be to 3 decimal places. The shadow of the building is approximately 1435.550 feet long. So the shadow, that's this part right here, is about 1,435.55 feet long. All right. The last one we have here is from a point 300 feet from a building, the angle of elevation to the base of an antenna on the roof is 24.2 degrees, and the angle of elevation to the top of the antenna is 34.6 degrees. Determine the height in feet of the antenna. So we've done these problems before, but again, we're doing them on the calculator. So here's my picture, here's my building, here's the antenna. We have one triangle that's created from the point out here from the bottom of the building to the top of the building, which is 24.2 degrees. And then we have a bigger angle that goes from the bottom of the building to the very top, and that gives me that bigger triangle. So I'm going to be using, and I'm trying to find tangent because I need to be using the adjacent side and the opposite side. So the first thing I did, let's see if I can get it all on here so you can see. All right, so the first thing I did was to figure out the small triangle. So that's this side right here. So I said tangent of the small angle, which is 24.2 degrees, equals A over 300 feet. I multiplied both sides, the 300 over here to get rid of it, get A by itself. And remember, my quote marks means that I'm going to store this information. So I'm actually going to go into my calculator and I am going to do, let's see, what mode do I need to be in degrees? So I'm going to press that and check. I'm in degrees, so I'm good there. And I'm going to do 300 tangent 24.2 degrees. And then I'm going to press the store button, and then I'm going to put it in alpha A. Just remember, you can store all in that same step. So now that I have A stored, then I can calculate the other side, which is this whole length with the big angle. So I'm going to have what I calculated with A plus X, so I get this whole length, so I can use this big angle that goes from here to here. And so then to get those things by itself, I'm going to multiply both sides by 300, and then I'm going to subtract the A over to the other side. So then when I go back to my calculator, I have 300. Then I'm going to do tangent of 34.6 degrees. Oops, 34.6 degrees. And then I'm going to subtract alpha A. And so I already have that stored in my calculator there. So when I hit enter, and I get 72.135 feet. And in the context of the problem, the height of the antenna is approximately 72.131 feet. And we're talking this distance from here to here. So that's what we just calculated. Okay, thanks so much, guys. Remember, draw your pictures, check your modes on your calculator, and pay close attention when you're working with calculator problems so that you round to the right places, you use the right signs, and you definitely are in the right mode on each problem.